Welcome to solverfy.
Well, first of all, let me draw energy levels. Let's say this is one energy level. We call this energy level C, and we have the second energy level, and let's say this energy level is um, B, B, and the final energy level is, let's say, A, A. According to the given condition, um, the energy level of C is, let's say, 3 times E. It's 3. Likewise, the energy of second level or level B is 2E. And let's assume that the energy level of A is 0. I have taken the values of energy levels according to given condition. Well, it's obvious that the energy difference between C and B is E. So the difference between C and B is E. When we take the energy difference between like B and C, it is E. And the energy difference between B and A, it is 2E. We are told in the problem that when an electron jumps from C to B, or when an electron jumps from C to B, it emits electromagnetic wave. It emits a photon, and the wavelength of the photon is lambda is equal to 600 nanometers. Okay, now what will be the wavelength of the photon when an electron jumps from energy level B to A? And we notice that the difference between B and A, energy level B and A, is 2E. And we know that uh, energy equals H times C divided by lambda. This E is the difference between two energy levels. H is Planck's constant, C is speed of light, and lambda is the wavelength of electromagnetic wave. And solving for lambda, we get lambda is equal to Hc divided by E. Hc divided by E. All right. Okay. And for transition from C to B, this value is equal to 600 nanometers. 600 nanometers. When an electron jumps from B to A, let's say its wavelength is lambda prime, and lambda prime would be equal to H times C divided by the difference of energy levels, the difference between B and A, which is 2E, 2E. And we get this is equal to 1 divided by 2 times Hc divided by E. And we know that this term Hc divided by E is equal to 600 nanometers. So we get lambda prime is equal to 600 nanometers divided by 2. Therefore, lambda prime is equal to 300 nanometers. 300 nanometers. So this is our required result. So when an electron jumps from B to A, then the wavelength is 300 nanometers. All right. Now, what would be the wavelength of um, the photon when the electron like jumps from C to A? So what's the difference between what's the difference in energy between C and A? It's quite obvious that it is like 3A. Following the same logic, we can say that the wavelength would be the wavelength of emitted electromagnetic wave when an electron jumps from C to A would be 200. It would be 200 nanometers. It would be 200 nanometers. Okay, so we just followed the same logic we used here. Therefore, um, we get this value 200 nanometers. Okay, end of the problem. Thank you for watching.